Okay, good morning. Welcome to Pavitra classes. We are studying the next topic, that is the general principles of the spectroscopy. So please do follow us on YouTube channel is there. You subscribe to our Pavitra class channel. Follow on Instagram, Facebook page also. So what is spectroscopy? So introduction to spectroscopy. It is the measurement and the interpretation of the electromagnetic radiation EMR absorbed or emitted when the molecules or atoms or ions of a sample move from one energy state to the another energy state. So maybe from ground state to the excited state. Spectroscopy measures the changes in the rotational, vibrational and the electronic energies. So as we know, it may be involved with the atoms, it may be involved with the molecules. It will be inside some of the rotations, vibrations will be going on. Whenever it kept with the electromagnetic radiation, it will again change its stability and it will change to its rotational or vibrational or electronic behavior. So we are taking that, changing the behavior with the spectroscopic instruments. So next is the EMR radiation usually is made up of distinct particles, that is called as the photons. EMR has got both wave characteristics as well as the particle characteristics. The different types of the EMR are usually visible radiations will be there, UV radiations will be there, IR, microwave radiations, X-rays, gamma rays and the cosmic rays. These are the different EMR radiations can be seen in the universe. These radiations have the different wavelengths and the frequency and as well as the energy. This is the chart of the different EMR electromagnetic radiations. So you can see in these are varied with the different wavelengths and the frequencies. So here you can see X-ray, gamma rays, 10 raised to minus 10, 10 raised to minus 9, 3 into 10, ultraviolet, visible 3 into 10 raised to 8, infrared 3 into 10 raised to 6, 10 raised to 4, 10 raised to 2, 3, like this changes are there. So energy levels usually in the X-ray, gamma rays, atomic and the electronic transitions will be there. So it will be in the atomic level, ultraviolet and visible. In this both electronic and atomic and the molecular level will be there. Infrared usually molecular vibrations will be there. Microwaves molecular rotation will be there, and radio waves will be the nuclear magnetic energy levels. This is the major chart. This is also the same chart, wavelength in the nanometers, wavelength in the meters. So whatever these colors, Vibgyor colors, red, this Vibgyor, violet to red, this is the visible light what we are seeing in the normal eye. Other than that, infrared rays, UV rays, X-rays, gamma rays, radar, FM, TV waves and short waves and the AM. These are the universal EMR radiations in the one column only. Next is coming to the energy of the radiation is given by some of the formula, that is the E is equal to HV. This is the general formula for the energy of the EMR radiations. E means energy of the radiation, H is the Planck's constant. It will be stable for all the calculations, 6.624 into 10 raised to minus 34 joules per second. V is the frequency of the radiation. So what is the converted energy to ground state to excited state? What is the energy level of the particle? By this calculation we are doing. Frequency is equal to C by lambda. So C, what is C in this? Velocity of the light in the vacuum. Usually it is 3 into something, 3 into 10 raised to minus this, and divided by wavelength. Usually wavelength will be 1 by lambda. So it can be given as, therefore E is equal to, by taking in the first equation, Hc divided by lambda. So V we are taking as a V as a C by lambda. Next is the wave number. So wave number can be defined as 1 by wavelength. So E becomes Planck's constant, velocity C, Hc into V dash, that is the wave number by applying these two formulas. First formula we are taking HV into converting into the frequency, Hc divided by lambda. Hc divided by lambda again we are taking as the wave number, 1 by lambda as a wave number. So H, C and V bar. That is the E is equal to Planck's constant h, velocity c, and the wave number v dash. Next is the what is frequency, what is wavelength, and the what is the wave number definitions. Frequency, it is the number of the complete wavelength units passing through a given point in the unit time. Usually it is measured in the hertz. It is the complete wavelength unit in a point of a given time. So at a particular time, how much complete wavelength or complete waves are taken place. So it is measured in the hertz. Higher units will be megahertz and the kilohertz. Next is the wavelength. It is the distance from two successive maximas and two successive minimas. Distance between the two successive troughs and the peaks. It may be above the plane or it may be downside the plane. Measured in the usually in the meters. Wave number, it is the number of the waves per centimeter. So this is the wave diagram. So this is the two successive. Here you can see wavelength is the two successive distance between the two successive maximas. These upper are the maximas, these are the minimas. So here y is the amplitude. You can see here this is called as amplitude. If it is a wave, this is the wavelength, this is the amplitude, and this 1 by lambda is the wave number. Next is the types of the spectroscopy. Usually spectroscopy can be divided into types based on how it is measured. So whether the study is made in the atomic or molecular level, in that classification is done as atomic spectroscopy as well as molecular spectroscopy. If the atomic level study is there, that is the atomic spectroscopy, and the molecular level study is there, that is called as the molecular spectroscopy. Example is the atomic, X-rays, gamma rays. Molecular examples are IR, NMR. These are the molecular level study. Whether the study is based on the absorption or the emission based study. So the radiation will be absorbed, that is absorption spectroscopy, UV, IR, NMR, and atomic absorption spectroscopy. These are the examples. If the scattered light is emitted, emission spectroscopy, that is the flame photometry. Third is the whether the study is based on the electronic level or electronic energy or the magnetic level. So this is based on two types are there: electron spectroscopy, UV colorimetry, and fluorimetry. Magnetic is NMR and the ESR studies. So coming to the energy levels, usually rotational energy, comparing the rotational energy, vibrational energy, and the electronic energy, one ratio is there, that's the rotational energy is to vibrational energy is to the electronic energy. It is usually 1:100 is to 10,000. This is about the types of the spectroscopy. Next is the theory of the spectroscopy. So what is the theory of the spectroscopy? When EMR travels through a medium containing atoms, molecule, or ions, the intensity of the emergent light, that is IT, is it is equal to the intensity of the incident light. So whenever applying with the sample, intensity of the emergent light, whenever it is equal, that means there is no absorption in the between molecules. So whenever the intensity of the emergent light is less than intensity of the incident light, so incident light some part is captured as a absorption. So emergent light gives the lesser part. So there is a absorption of energy. By this basic principle, we are calculating the incident of the intensity of the incident light, what is the intensity of the last emergent light, and in between the absorption. This is the basic theory. Then the excitation process and the relaxation processes are very important in this. So whenever the absorption of energy takes place through the sample of light, followed by the transition from ground state to the excited state, where ground state is called as the most stable and the least energy state. Whenever the molecule goes to the excited state, it will get the more energy and it will be least stable. It will be again it will come to the ground state, that is called as the relaxation process, by losing the energy. Once the excited molecule reaches the excited state, it is not stable there only. So the atom loses its energy again, then it returns to the ground state. That state is called as the relaxation of the processes. This is the, if the molecule is in the ground state, it gains the energy and it goes to the excited state. Again it will transfer the energy to the unexcited molecules to the excited molecules. This is the vice versa procedure. It will go to the excited state. Again, it will loses the energy. Again, it comes to the ground state. Whenever it is in the excited state, it will absorb some of the light part, and we are identifying in that part, and we are doing the identification process, how much energy is captured by the molecule. So this is about the general principle of the spectroscopy, majorly used in the instrumentation methods. So thank you for the listening. Be with us for more topics. Thank you once again.